We've talked a lot about AI experimentation. You know, we've talked about proof of concepts and then taking that leap into production. This panel is talking about exactly that, doing that at scale and doing that in a way that, you know, has all the safety barriers around it, et cetera, but really looks to scale at some pace. Delighted to welcome our panel here. Liz Drummond, one of our senior vice presidents, is going to be leading and moderating the panel. We're also joined by Sarah Bryan, Jade Hind, and Scott Hackerson. Over to you, folks. Thank you.
You might have noticed the panel giggling as they sat down. It's when they noticed my photograph for the first time. I promise you it's not AI. It's just really old. So we are going to talk about production-ready AI in a bit of a panel format. I will pre-warn you, we're going to come for some questions and try and leave loads of time for questions, so please do think of some. But I'm going to kind of start with a bit of an opener and a general question to the panel. So generative AI has moved on massively in the last 2 years, like really, really accelerated. So I'm interested in your perspectives of how that has translated into real changes in the software development lifecycle. And I'm going to start with Sarah, actually. So how have you seen the software engineering ecosystem evolve?
Sure, okay. So I think, you know, in terms of the biggest changes that we've seen through AI, we've heard a common story throughout all of the talks this morning, I think. It's been a big shift from having, you know, a chatbot assistant who can answer questions to something that's a lot more integrated into your workflow and able to pick up quite a lot of the heavy lifting. And there's been, you know, a number of technical improvements that have driven that advancement. Can talk about, you know, reasoning models and long context windows. But I think, you know, we're kind of reaching a point where what you can get out of the model alone sort of maybe plateauing. And then the step change really is tools and systems integration, right? So that's taken us a long way forward. Just to give you a couple of examples, right? Models are trained at a snapshot in time. So if you wanted to ask a question about what's the latest news or something like that, you need to enable the model with a web search tool. Models aren't really good at data analysis or producing graphs. Give them a Python environment and it's a different story, right? And I think, you know, all of those things have sort of driven a really rapid advancements in terms of capabilities and opportunities. But I think also from the human side, right? AI has sort of opened up opportunities to a broad range of people. So we're seeing a lot more different approaches and different, you know, ways of thinking and things like that. So that's all sort of contributing to the rate of change. And I think, you know, we've seen it impacting most predominantly in software engineering because it's a bit of a proving ground for AI. Obviously, you can integrate into the systems and you can get those really fast feedback loops. So I think that's been, you know, that's been a big driver. And then in terms of the SDLC, we're certainly seeing it right across the board, right, from requirements and planning through to testing and maintenance.
Yeah, fabulous, thank you. Cam?
So I'm going to kind of pick up at the point that you were making before, and it's been made again and again in the conference as well, which is the rapid rate of development. So I work in research and innovation. So we kind of use the latest models, the latest tools, and when we're having conversations with clients, we kind of always have to tack on this word now, which is yet, not yet. If we're having the conversation like 6 to 8 months ago, we were talking about a project that we were doing, and we evaluated what the current capabilities of generative AI were then for being able to complete that task, complete that project. And we said, with the environment you have, so they wanted to use local models that were open source, which means that we had to use our own consumer-grade hardware. We said, look, the models that would be able to serve this, they're just not capable of doing what you wanted to do. Yet, 6 to 8 months later, we're having this same conversation. It is very different. And that's such a short amount of time, especially in technology. And it's probably one of the most rapidly developing fields that I've seen in a very, very long time. So.
Thank you. Just hold on to it for a second. Otherwise, I won't know what to do with it. I've got a question for Scott then. So as a kind of a testing expert, we've heard a lot about the impact on the software engineering lifecycle. And Tom talked a lot about this morning around the human impact of AI on software engineers. So what's your view of the impact specifically on testers? And will we even need them in the future?
Okay. Try to answer that without getting fired. Yeah, I think, to me, testers are going to still be completely needed, or 100%. If anything, I actually think it's going to be more needed than it ever has been, because testing is so much wider than just simply writing an automation test or, just testing one thing. We preach about quality engineering and driving that through our processes. So as we take this work in, we've still got to think about how we get it through to production. We've got to think about our pipelines, our route to live, our governance, our testing, our integration to stuff, our performance, and all that sort of stuff. So I think it's still 100% going to be needed. That being said, I think it is going to evolve. So as we've talked about from a development point of view, everyone's now starting to play with these coding assistants. Testers are having to do the same thing, right? So we're having to think about how testing is being impacted from these tools. How do we make sure that testers stay up to speed? We can create, we're seeing some fantastic stuff around coding assistants being able to help create automation frameworks at rapid speeds now, and onboarding onto projects being great. We're seeing AI badge up in all these different sorts of phases of testing, from defect stuff, from triaging of requirements, breaking those down, MCP servers helping for Jira and Confluence updates as you're going through. So it is rapidly evolving, and we do need to stay with how that's going to change from a testing point of view.
Thank you. So let's move on to talking then about productionizing AI. So Tara in the opening this morning talked about being production ready and us needing to get to a point where those proof of concepts are going to be production ready. Jade, what should people consider when they're doing a proof of concept to enable it to become production ready in the future?
Yeah, okay. I've got two sides of the coin on this, really, and it's a lot of the times when you're producing a proof of concept, people kind of put it through really fast, and that's good. You want to fail fast, you want to know if it's capable of doing something, but also they don't necessarily consider the design of end-to-end or what that needs to look like or how that needs to work. So there's two sides to this for me. There's what AI can and should do and what its capabilities are, and then there's the other side of understanding what your processes are and knowing how to break those down. So I'm going to give an example, and I'm so glad that, Louis, you brought up the fact that documents are really hip. I don't think you said that word, but I'm going to say it. But it is really important. And so my expertise is natural language processing, and about 80 to 90% of the work that I do is processing documents. It might seem boring, but it's so effective. So when I talk about this, I'm going to give a naive example of, I want to answer 20 questions about analyzing a document. I want to know information about it so that I can get exactly what I want. A lot of people, when they're doing this proof of concept, they send those 20 questions to the API, say, answer it, give them the output. It works, it does the information. It might not necessarily give you all the answers that you want for one of the questions. It might miss one out, it might do all but when you're trying to put that into a workflow, that's no good. Because when you're trying to get the information out, you want the information for question one, but maybe you've got a new line, maybe you've got a different type of bullet point, all the formatting goes wrong. And if you think about that from a human process, how do you answer questions? If you were given 20 questions, you look over the 20 questions and then you start answering them. You answer question one first. Then when you've answered question one, you'll go into question two. You might find that some of the information that you'd include in question two, if you've only seen question two, is actually in question one. So you're not going to add it in question two. But what models don't have is memory. They don't have the context. What you send to them is all they're seeing, and they're based on their training deck, exactly what you said. That's where they're stopping. They don't have any more information there, so you need to give them tools, you need to give them memory, you need to give them context. So when you have this question one, when you're answering question two, tell it what it answered for question one so that it understands that. And when you break that workflow down, you can then produce a machine-readable data, JSON format, whatever you want to call it. It is called JSON, or whatever format you want to use. And then that can then be ingested into a database. And when you do that, you don't have to worry about the formatting issues. You don't have to worry about whether or not you can evaluate this, because now you can apply deterministic functions to the information that you've got out of it. You can see where the errors are. You can then understand, one of the biggest problems that you have is compounding errors. You have a workflow. You use an AI here, you use an AI here, you use an AI here. If something goes wrong here, it gets worse here, it gets worse here. So you need to be able to spot them as well. I think I've gone off at a tangent, haven't I?
That's absolutely fine.
Yeah, also I think certainly going the end-to-end is crucial, right? And from two components, I think it's also really important to be clear on your success criteria, right? What are you trying to get out of that at the end of the day? Spend a lot of time looking, oh, the model's producing good results, or, it's returning answers that look sensible. But ultimately, like if you're building a chatbot who's going to be an assistant, acting as an assistant, the driver is more reducing handling times or reducing customer complaints, and sort of building that in from the beginning, I think, is important.
Yeah. So Scott, you work quite a lot with proof of concepts. Have you got an example of productionizing it or having that in mind as you're doing your proof of concept?
Yeah, it's a good question. We're working on one at the moment, I guess, on one of our government clients, where for context on what we're doing. So we've been challenged by the client to come up with timelines to help rapidly modernize some old Java 7 applications all the way up to Java 25 and do it in condensed timelines. So the obvious answer for that is AI. How do we use AI to drive that life cycle, to iterate through that? So to enable us to do it, though, we started by doing it in sort of a CGI sandbox world. So we're using these tools to recreate the client's architecture of their applications, to not use their code base, to basically simulate their applications, and then prove our theories of rapidly evolving those through. Now, that's great, but then how do we translate that into the client's world? So we're starting to have those conversations with them about, what does that look like? How would this work inside your world? What are the security governance? How would we do this? But then also, how do we scale it? So lots of the conversations I've had with people is, that's great, but how do you scale this across agile teams? How do you get all of your different partners involved in different stages of that life cycle? So that's part of the experiment we're driving now. We're entering to the next phase where we're rolling it out across the team to start thinking about how we get people involved in that, and then how do we work with the client to take it through to a productionized service as well.
Fab. If anyone has got any questions that we haven't answered, these are the guys you want to go and see in all the breaks.